Welcome to another solution video. In this question number 1, they're asking us to integrate this particular function. So since they have a positive in between them, so let's separate them. I can write x cubed dx separate and 1 over x cubed dx separate, right? If we have a denominator which is a variable with an exponent, we can write it as x to the power minus 3, except for 1 over x. That is different. We can't write 1 over x as x to the power minus 1. Any other exponent we can write like this, even if it is a fraction or a negative number. So let's rewrite this here. And now we can integrate this one as x to the power 3 plus 1 over 3 plus 1. Here it will be x to the power minus 3 plus 1 over minus 3 plus 1. And as a ritual, we will write plus c. Let's complete it here. So we get x to the power 4 over 4 plus x to the power minus 2 over minus 2 plus c. And now we can write it in this format. 1 over 4x to the power 4, this one. And this minus can come in front here now, minus 1 over 2 and x square. Because this is a negative exponent, to make it positive, we make a denominator plus c. This is the integration of this function. Let's move on to the second question, which is find the terms in x square and x cube in the expression 1 minus 3 over 2x. Okay, so only x square and x cube. So for that we need a formula which is here. We will use binomial expansion a plus b and this is how it will go. So n1 means nc1, which is there on your calculators. So we'll write this way. 1 minus 3 over 2 x to the power 6. Now since we want x square only, so we will focus only on the one which will give us x square. And if you notice here, I'm not saying equal to, but yeah, minus 3 over 2 is our second term inside the bracket x. We want square so that this x becomes square, right? And that's how the n is 6 in this case, the exponent here, c2, this number and this number must match. And remaining 4 exponent, this is 2 exponent, 2 plus 4 should be equal to 6. 4 exponent will go to the other term in the bracket. Minus 3 over 2 has been taken already, so 1 will be written here. And let's talk about the cubic also. Same thing. Minus 3 over 2 will get, x will get a cubic exponent. Here it will be 6, c3. Again, this number and this number match. And remaining 3 will be for 1. And we'll just find these two. Others are not asked, so we will not even look at them. So 6c2 is 15. Minus 3 square will be 9 over 4 x square. Have each term squared. 1 doesn't make any difference, so we'll leave it. Plus 6c3 is 20. Minus 3 cube minus 27 over 2 cube 8 x cube and 1 cube is 1, we don't write it. So 15 times 9 is 135 over 4x square plus 20 times 27 minus it will be 540 over 8 x cube. Okay, second part is also there. Given that there is no term in x cube in the expression of this one, find the value of k. Alright. That means if we multiply the two, there will not be any x cube as a result. So part 2 is k plus 2x multiplied by the one we got in the first part, 135 over 4x square minus 540 over 8 x cube is equal to 0x cube. And why did I select only these two and only these two? Because a constant multiplied by cube will give you a cube, and x multiplied with an x square will also give a cube. There is no other combination with this bracket that will give us a cube, and that's why it's not important to write any other uh, term of the expansion of that binomial. For that matter only, they asked you just these two. Okay, so let's multiply k with this. K multiplies with minus 540 over 8x cube. It will give you x cube, correct? Now 2x multiplies with 135 over 4x square. It gives you x cube, which will be equal to 0 x cube. What does this become? Minus 540 over 8k x cube plus 270 over 4x cube. 2 times 135 is 270, okay? Equal to 0 x cube. All of them have x cube, so let's get rid of x cube. We will be concerned only with the coefficients. So we have minus 540 over 8. Let's bring it to the right side and keep 270 over 4 here. So minus 540 over 8k will become positive 540 over 8k. And now we want to find the value of k. Let's keep k here and cross multiply this. 8 multiplies with 270. And 540 multiplies with 4. So 4 times 2 is 8. 270 times 2 is 540, and 2 and 2 cancel. Nothing left, everything cancelled out. That means k is equal to 1. Not 0, okay? 1. Alright, let's go to the next one. The equation x square plus px plus q equal to 0, where p and q are constant, has roots, these two. Find the values of p, q. So if we know the roots, we can use remainder theorem. According to this, if I substitute the root into the main polynomial, I should get a 0 remainder, right? 0 value. So let me do this. So when root is minus 3, what do we get? If I substitute in the main equation here, minus 3 square plus p minus 3 plus q equal to 0. So it becomes 9 minus 3p plus q equal to 0, and that gives you an equation. Q minus 3p equal to minus 9. I rearranged it. This is equation number 1. Okay. When root is 5. So 5 square plus p times 5 plus q equal to 0. This 25 plus 5p plus q equal to 0. So I can rearrange it. 5p plus q equal to minus 25, question number 2. Let's eliminate q because q is in both, right? So let's subtract this equation number 2 from 1. So I will write it under the previous equation, q plus 5p equal to minus 25, and subtract. So this cancels out. Minus 8p equal to minus 16, no, plus 16. Yeah. So p equal to 16 over minus 8, which is minus 2. And let's use this equation to get the value of q. 5 times minus 2 plus q equal to minus 25. So this becomes minus 10. Q equal to minus 25 plus 10. Because it changed its position, it became positive. So q equal to minus 15. Now, using these values of p and q, find the value of constant r, for which the equation this has equal roots. It has one root, p square, okay, same thing, plus r, okay. X square plus px plus q plus r equal to 0. We know p is minus 2, q is minus 15. So x square minus 2x minus 15 plus r equal to 0. And we know that it has two equal roots. That means it has only one single root. For that, discriminant b square minus 4ac has to be equal to 0. So for us, b is minus 2, a is 1, and c is this whole thing, minus 15 plus r. Okay? So b square minus 2 square minus 4 times a, and c is minus 15 plus r equal to 0. So 4, and this becomes minus 4 minus 15 plus r equal to 0. It becomes 4 plus 60, yeah, plus r, no, minus 4r equal to 0. 64 minus 4r equal to 0, minus 4r equal to minus 64. Divide both sides by minus 4. It cancels here and we get positive 64 divided by 4, 16. R is 16. Okay. A curve has an equation this. Point P22 is point on the curve. Okay. 2, 3 times 2 is 6. 6 minus 4 is 2. 4 over 2 is 2. That's correct. It is on the curve. Find the equation of the tangent to the curve at P. Equation of the tangent. Alright. So equation of the tangent is y minus y1 equal to mx minus x1. y1 and x1 are the coordinates of the point on the curve which is given to us 2, 2. So in place of this y1 we can write 2. In this place of x1 we can write 2. X and y need not to be replaced. Only thing needed now is m. So let me calculate m here. M is nothing but the differentiation of the equation of the curve, okay, at that particular point when x is 2. So let me differentiate this 4 over 3x minus 4. They are dividing, so I can rather do this way. Y equal to 4 is the numerator, 3x minus 4 to the power minus 1 I will write. I don't want to use quotient rule in this because it is very simple. So dy over dx equal to 4. This minus 1 comes and multiplies with 4. So minus 1 comes in front. 3x minus 4 to the power minus 1, and it goes down further by 1. And we have to further multiply by the differentiation of what is inside the bracket, which is 3. 3x, differentiation of 3x is 3. Differentiation of minus 4 is 0. So we will just multiply by the differentiation of 3. 3x. So 3 is the one. Let me write it here. So what do I get? 4 times 1 times 3 minus 12. And x to the 3x minus 4 to the power minus 2. No need to simplify this because we are not going to use this straight away. We have to first substitute 2. So let's substitute 2. Now what is m now? M when x is 2. Okay, that is what m is. Minus 12. 3 times x is 2 now. Minus 4 to the power minus 2. You can put this in your calculator. I am doing it mentally. Minus 12, 6 minus 4 to the power minus 2, which is 2 to the power minus 2. Minus 12 over 4 minus 3. M is minus 3. And we get the equation now. Any format they want? No. What angle is this particular line makes with x-axis? So let me try to visualize this. I'm just randomly drawing it. So this is the angle it is making with x-axis, this one, right? And this is nothing but tan theta if I somehow complete a triangle on this, right? And the word tangent, we got the equation of tangent is the full form of tan. So basically, the summary is whatever is the gradient, that is the tan theta. So let's find the gradient in 3x. We know y equal to mx plus c is another format of writing an equation of a line. So let's convert that one. It was already there, but let me do it. 3x plus y minus 9, so it will become y equal to minus 3x plus 9. It means the tangent is minus 3. Minus means it's going down. It is not this way. It will be this way. Now they're saying find the angle that tangent makes with x-axis. They said just x-axis. Which direction, positive direction or negative direction, they did not tell. So let me focus. I will find either this angle or this angle, all right, which is with positive x. So I will say tan theta is minus 3, theta equal to tan inverse minus 3. Now there is a possibility that I will get an obtuse angle or a negative angle. Whatever I get, I will assume that as an answer. So when I put this in my calculator, I get minus 71.56 degrees. Minus 71.6 degrees is the angle this line is making with positive x-axis. If someone takes negative, this will be the angle. Question 5, we have to prove this identity. Let's focus on left-hand side. Cos theta remains cos theta. Tan theta can be written as sin theta over cos theta, and it is 1 minus sin theta. And why did I do this? Because right hand side has just sin theta, that means tan theta must have to go. Okay, now it becomes what? This cos theta is a denominator of the whole thing because they are multiplying, right? So it can multiply with the numerator. In short, denominator of a denominator becomes numerator. So we have two cos thetas multiplying on top. Sin theta 1 minus sin theta. Now, if we compare with our target on right hand side, we must have a sin theta at denominator, which we have. That means we have to get rid of this one. So we should plan that way. Cos theta times cos theta is cos square theta over sin theta 1 minus sin theta. Now, cos square theta can be written as 1 minus sin square theta. And denominator will be sin theta 1 minus sin theta. How did I get this numerator like this? Because we know there is an identity that sin square theta plus cos square theta is equal to 1. So if I keep cos square theta on the left side, but move sin square theta to the other side, it becomes cos square theta equal to 1 minus sin square theta, and that's what I've done here. So let me undo this. Next target is to get rid of 1 minus sin theta. Okay? So to get rid of this, it should cancel out with something on numerator. So can I do this? 1 square minus sin square theta. Can I change it like this? Because 1 square is 1. And we have one more identity, which is a square minus b square equal to a minus b multiplied by a plus b. So it is a perfect square minus a perfect square, just like this. So we can write our numerator in this format: square root of the first term minus square root of second term and then positive. So my numerator becomes 1 plus just sin theta, not square anymore, 1 minus sin theta over sin theta 1 minus sin theta. And the purpose was to cancel this because both are multiplying now and they can cancel out. We are left with 1 plus sin theta over sin theta. And to meet our target 1 plus 1 over sin theta, we should separate the numerators now. So 1 over sin theta plus sin theta over sin theta. They cancel. And finally we are left with 1 plus sin theta plus 1, which is exactly right hand side. Yeah, the sequence is different, but yeah, it's positive, so we can write it anyhow. Part 2, hence solve the equation, this one. if you see this part and this part, they match exactly. That means in place of this, we can write the right hand side, 1 plus 1 over sine theta equal to 4. So 1 over sine theta plus 1 equal to 4. This becomes our equation, and our domain is that theta is between 0 and 360. This is part 2. So we have a denominator here. Let's get rid of this denominator by multiplying the whole equation by sine theta. So sine theta multiplies with 1 over sine theta, we get just 1. Plus sine theta multiplies with 1, we get sine theta. And then we get 4 sine theta. Let's combine sine theta and sine theta so that we can simplify this. 1 equal to 4 sine theta minus sine theta, which is 3 sine theta. 1 equal to 3 sine theta. Let's divide both sides by 3. So that 3 is gone, and sine theta is equal to 1 over 3. Which gives us theta is sine inverse 1 over 3. Now look, our domain is from 0 to 360, and we want sine inverse 1, 3, which is positive. And sine is positive in first and second quadrant of the 360 Cartesian plane. So if we find sine inverse 1 over 3, these acute angles will be equal to that one. That's the rule, right? So if I put sine inverse 1 over 3 in my calculator, I will get the value of this. By the time I do this, I request you to subscribe to my channel, like and share this video with your friends so that they also get benefited. And I'm motivated to make even more videos like this for you. So theta equal to sine inverse 1 over 3 gave us 19.5. So I write 19.5 and 19.5 acute angles with horizontal lines only, always. And to find the value of this, we start from 0 degrees here and see where the lines are drawn. So this is the first line. First line is 19.5 degrees itself. That's our first answer. Second answer, we start from 0 and go to second line, which is 19.5 degrees less than 180 degrees, because if we reach this line, it is 180. So it will become 180 minus 19.5, which is 160.5 degrees. Moving on. A function is defined as this. So please be careful. F, these two colon, and x is same as fx. So we can say that they're saying fx is equal to x plus 3 over 2x minus 1. Okay. Show that fx is x. Okay. So fx is same as f of x. Right? So let's substitute the bracket inside by its value, fx, by its value, which is x plus 3 to x minus 1. So this will be f of x plus 3 over 2x minus 1. What it means? That whatever x's we have in this particular function, substitute those two x's by this whole expression. So let me do this. The first x is replaced by x plus 3 over 2x minus 1. Then we have plus 3. The denominator 2 remains 2, but x is replaced by x plus 3, 2x minus 1. And then we have minus 1. Our target is to get x. That means everything, most of them should get cancelled out. And how can that happen? If we merge these two parts, and for merging, we have to give it the same denominator as the left one. So we will multiply also by the same expression and divide. Effectively, we multiply this by 1. Same thing here, 2x minus 1 divided by 2x minus 1. Now, since the denominators are same for this part, numerator part of this rational function, let's write that once, 2x plus minus 1, and numerators will be x plus 3 is x plus 3 plus 3 multiplies here, 6x minus 3. What about denominator? Again, we have same denominator 2x minus 1. We write 2x minus 1. And please, some of you have a misconception that this 2 multiplies with both numerator and denominator. No. 2 multiplies only with the numerator whenever there's a single number multiplying with a fraction. So it will be 2x plus 6 minus 1 multiplies with 2x minus 1, 2x plus 1. Okay? So both have same denominator, so we can cancel that out to make it simple. 3 and 3 also cancel out. See, it is happening. That's the one we needed. X plus 6x is 7x. And in denominator 2x and minus 2x cancel. 6 plus 1 is just 7. And 7 cancel out. We get x. That was what they are asking us to show. Part 2. Hence or otherwise obtain the expression for f inverse x. So we just got fx equal to x. That means one of them, either this one or this one, is the inverse. Then only it will happen that the content of the function becomes equal to itself. Only it is possible only if fx, this fx, is equal to f inverse x. That means the inverse of the function is itself. So what is the function itself? It was x plus 3 over 2x minus 1, and that is the inverse. There are other detailed methods also, but since it is just worth how many marks? 2 marks. This is a straightforward relationship you can show. And here is question number 7. The line L1 passes through point 25 A and 10, 9 B. Let's draw it. So 2, 5 is A and 10, 9 is B. And this is L1. The line L2 is parallel to L1, okay. They're parallel. And passes through the origin, okay. Somewhere is origin. This is not to the scale, okay. I'm just, for the simplicity's sake, I'm drawing like this. The point C lies on L2, okay, this is L2, such that AC is perpendicular to L2. A and C. That means this point is C. Perpendicular to L2, find the coordinates of C. So find the coordinates of this C. Let's say they are MN, okay. Now, if this is 90 degree, this will also be 90 degree, right? So if I find the gradient of this line L1, let's find the gradient of L1. We know the formula for gradient is, let me write here, y2 minus y1 over x2 minus x1. This is the gradient. And let's find the gradient of L1 because we have 2 points which are needed. y2 minus y1 over x2, is it 0, 9? No, it is 10, 9. x2 minus x1. 9 minus 5 is 4, 10 minus 2 is 8, which is half. So the gradient of L1 is half. Gradient of L2 will also be half, and that means the gradient of AC, which is perpendicular to both of them, will be negative reciprocal of half, which is minus 2. So let's find an equation in terms of M and N of these two facts. So first one, gradient of AC will be again y2 minus y1 over x2 minus x1, and we know it is minus 2. Yeah, we just found out. Let's cross multiply. So n minus 5 equal to minus 2 times n minus 2, n minus 2, n minus 5. equal to minus 2m plus 4. Let's bring minus 5 to the right side and minus 2m to the left side. So n plus 2m equal to 5 plus 4, 9. Equation number 1. Second situation. We know that the gradient of this L2 is half. So we know this point 0, 0, and we don't know m and n, but we'll use the same way. Y2 minus y1 over x2 minus x1 equal to, the gradient is half for L2. Cross multiply again, so m times 1 is m, 2 times n is 2n. 0 is not looked at. Okay, m is 2n, so we got m in terms of n, so let's use it here. N plus 2 and m is now 2n equal to 9. N plus 4 and 5n equal to 9, that gives us n equal to 9 over 5 equal to 1.8. And m equal to 2 times n, and we got the n value now. 2 times 1.8 equal to 3.6. So we got the gradient, not gradient, coordinates of C, which they were asking. 3.c is m and 1.8 is n. Next is to find the distance AC. We know the coordinates of A and C both. Now we can find the distance AC. So A is 2, 5 and C is 3.6, 1.8, and we want to find this distance. We'll use distance formula to find this distance, which is square root x1 minus x2 square plus y1 minus y2 square. So we know x1, y1 both. 2 minus 3.6 square plus 5 minus 1.8 square. So if we put this in our calculator, we'll get our distance straight away. What I'm getting here is 3.58 units. Question 9. The function f is such that fx is equal to 3 minus 4 cos to the power kx, and this is the domain 0 to pi only, all right, where k is a constant. When we read such a question, this straight away frightens us and we lose our confidence. Please never do that. Read the whole question, maybe it will become easier. See, here they're saying in the case when k is equal to 2, so you're not going beyond square. Find the range of f. Well, the range is the possible y values, which are nothing but fx. What are the possible values of fx? That is called range. Okay. Now fx is equal to, because k is equal to 2, it becomes 3 minus 4 cos square x, right? 3 is a constant, minus 4 is a constant. That means cos x is the only variable which decides the range, which will decide the range. So let's draw the graph of cos x. This is how the cos x graph will look till pi. Yeah, because our domain is till pi only. So this value here is 1, this value here is minus 1. This is the graph of y equal to cos x. However, if we want y equal to cos square x, which will decide our range, it will be different. What is the square of 1? 1. What is the square of 0? 0. What is the square of minus 1? Is also 1. So basically our graph will be something like this. So the maximum value we can have of cos square is 1. Minimum value we can have is 0. And this will decide our range now. So let's put first value. So when cos x is, cos square x rather, is 1. right? So what will be the range? Let's see. 3 minus 4 times 1, which is minus 1. This is one of the values. When cos square x is 0, that will be the other extreme value. 3 minus 4 times 0 is 3. So clearly this is our minimum value for y, this is the maximum value for y. So what does our range become finally? Range becomes minus 1 less than equal to fx less than equal to 3. This is the maximum value, this is the minimum value, they are equal, they are existing at these points also, this becomes range. B part, find the exact solutions of the equation fx equal to 1. Okay. Fx equal to 1, that means 3 minus 4 cos square x equal to 1. Let's take 3 to the other side, minus 4 cos square x equal to 1 minus 3. Minus 4 cos square x equal to minus 2. Divide both sides by minus 4. This cancels out and we are left with half, which means cos x will be, will square root both sides, plus minus 1 over square root 2. And we want answer from 0 to pi, that's what they said. So this is 0, this is pi. And plus and minus both means we will use the quadrants both plus and minus, because cos is positive here, cos is negative here, but both of them are there. We'll put now x equal to cos inverse 1 over square root 2 to find these acute angles. And it is pi by 4 and pi by 4. So what is your first answer? X1 will be, again starting from 0, just like the previous question, pi by 4. X2 will be this angle up to here, which is pi minus pi by 4, which is 3 pi by 4. These are the two answers. Let's move on to the next one. In case k is equal to 1, that means fx becomes 3 minus 4 cos x. Sketch the graph of the same function. All right. So in this case, let me rearrange this, and I can write this as fx equal to minus 4 cos x plus 3. Right? So this becomes the amplitude. This becomes the axis. And minus will reflect the whole graph of cos x. So first thing we should do, with the help of axis and amplitude, we should find the maximum and minimum. So since the axis is y equal to 3, this is 3 is axis. So 1, 2, 3. This is axis. Our graph will be above and below this axis. Now amplitude is 4. That means 4 below this, 1, 2, 3 and 4. Minus 1 will be the minimum. Axis minus amplitude is minimum. Axis plus amplitude is maximum. So 1, 2, 3 and 4. It is maximum. Next thing we should do is to find the period. And period is 2 pi divided by the coefficient of x. Coefficient of x is 1. So 2 pi itself is the period. So let's say that this up to this level is 2 pi. We want up to pi only. But since we take help of the full period, we'll draw the whole graph and then we'll erase after pi. Okay. So cos graph, because of negative, it is negative 4, right? That means usually the cos graph starts from maximum. Yes, but because of this negative, we'll start from minimum. Next 1/4, it reaches at axis, then it reaches at maximum, then at axis, and then at minimum. This will be the graph from 0 to 2 pi. However, I'm erasing after pi, so I will draw till pi only. That's it. There is no need to show after this. Part B, state with a reason where f has an inverse. Whether f has an inverse, whether it is one-to-one function or not, draw a horizontal line. Okay? And see if horizontal line passes through only one point at a time. Is it passing one point? Look at this white horizontal line crossing the graph. It is crossing at one place, only one place, only one place. That is true. That means since, let me write it here, since this graph, and in place of graph you can write function also, is one to one, it has an inverse. Question 10. Question 10. A circle is divided into 6 sectors in such a way that the angles of the sectors are in arithmetic progression. Alright. So if we have a circle, let me draw a circle, and it has 6 parts. The first part will be very small, second part will be little bigger than this, and similarly they will keep on increasing, and finally we will have 6 parts which will be in arithmetic progression. This is A, this will be A plus D, this will be A plus 2D, similarly 3D, A plus 4D, and A plus 5D. Alright, these are the 6 parts. The angles of the largest sector is 4 times. This is the largest, A plus 5D is the largest sector. The angle here is 4 times the angle of the smaller sector, this one. Okay, so A plus 5D is 4 times the smaller sector A. So let's simplify this one, it will give us an equation. For that, let's bring this A to the other side. So 5D equal to 4A minus A, 5D equal to 3A. This becomes our equation number 1. Second information they've given is, given that the radius of the circle is 5, R is 5, find the perimeter of the smallest sector. Okay, we have to find perimeter of the smallest, this one, the smallest one. Alright, so in this smallest sector we already know that this is 5 centimeters, that is the radius they've given. This is 5 centimeters. Only issue here is to find this arc. Okay, can we get one more equation because we have 2 variables? So they have not given any other situation, but we know that the sum of all these sectors, 6 sectors, will be 360 degrees. They are the angles. We know all the angles of a circle add up to 360 degrees, and that's what we can do. We'll use the sum of arithmetic progression formula here. So let me write it somewhere. Let me write here. Sn equal to n over 2, 2a plus n minus 1 d. This formula is given to you in exams. So we'll use this one. So S6 will be 6 over 2 and 2a, 2 times first term, we don't know a, plus n minus 1, 6 minus 1, 5, d equal to 360 degrees. Alright, can we cancel out? Yes, we can cancel this 3 here. So this becomes 3 times 2a plus 5d equal to 360 degrees. So let's divide this by 3, this by 3, so that we are left with 2a plus 5D equal to 120 degrees, because 3 and 3 cancel, and 360 divided by 3 is 120. Here we have been given in first equation that 5D is equal to 3A. Let's put this 3A in place of this 5D. So 2A plus 3A equal to 120. It is from equation 1. 5A equal to 120. Divide both sides by 5. A is 24 degrees. The smallest sector, its angle is 24 degrees, and now we can find the arc. How do we find arc? Arc is the ratio of this angle at the center, 24 out of 360 degrees, multiplied by the circumference of the whole circle. That is how we find the arc. So because the angle we are using is in degrees, we are not using radians, so it will be easier to do this way. We could have used radians also, but we will do it. R is 5. They've given R is 5 centimeters, right? So in place of R, we'll write 5 centimeters here. So 24 times 15, 5 times 3. So arc comes out to be 2 pi over 3. Now we will write the perimeter, because we know this one. Perimeter will be 5 plus 5 plus 2 pi by 3. This is the arc. And if we write 5 plus 5 is 10, and if we put this in our calculator, we get 2.1. So total perimeter is 12.1 centimeters. Okay, B part. The first, second, and third term of a geometric progression are these, geometric GP, okay, respectively, given that all the terms of the geometric progression are positive. That means if we get a negative value for any of the terms, we will not accept it. Calculate the value of the constant K. Since they are first, second, and third terms, we can easily say that second term divided by the first will be R, correct? Common ratio. Same will be A3 divided by A2 will also be R, and this is what will give us our equation. A2, second one is K plus 6 divided by first one is 2K plus 3, third is K, and second again is K plus 6. Now we'll cross multiply to make it simple equation. K plus 6 square equal to K times 2K plus 3. Now a perfect square will be like this one. The identity I always use is this one, A plus B whole square. It is equal to A square plus B square plus 2AB, right? That's what we'll do here. A square is K square, B square is 6 square plus 2 times K times 6 equal to K times 2K is 2K square plus 3K. So here we get K square plus 36 plus 12K equal to 2K square plus 3K. Let's bring everything to the right side rather. 0 equal to 2K square minus K square will be just K square. 3K minus 12K will be minus 9K, and this 36 will become minus 36. Now we have to find the value of K, and we can use your calculator or factorization method or quadratic formula, whatever is your preference. Let me use factorization. So K square minus 12 times 3. So 12K plus 3K minus 36. So K minus 12 and 0 equal to K plus 3 and K minus 12. So this gives us first answer K plus 3 equal to 0, which is K equal to minus 3. This gives us K minus 12 equal to 0. It gives us K equal to 12. And minus 3 we will not accept because one of the terms was just k. Yes, the third term. The third term was just k. And they said all the terms are positive. That means minus 3 will not be accepted. So k equal to 12 is accepted. So what is the question now? The value of k, we found k equal to 12. Second, the sum to infinity of the progression. Alright, let me do it here. Sum to infinity is a first term 1 minus common ratio. We know the first term, rather let's find it. The first term was 2k plus 3 as far as I remember, 2k plus 3, yes. So let's find a, the first term, 2k, k is 12 plus 3, 12 times 2 is 24 plus 3, 27. That is the first term. Now we have to find common ratio, and again we had common ratio here, a2 divided by a1. So a is already known to us, k plus 6 is a2. So k plus 6 over 2k plus 3 equal to r. K is 12 plus 6 over, and 2k plus 3 we already got 27, which is 18 out of 27, and 9 times 2 is 18, 9 times 3 is 27. R is common ratio is 2 over 3, and now we can find sum to infinity for this, a over 1 minus r. A is how much? 27. 1 minus 2/3. You can straight away put this in a calculator and you will get 81 as sum to infinity. Okay, the final question is number 11, in which they have given a graph of this function, and this is the equation of the function. The curve has a maximum point at m, we can see that, and meets x-axis at a. Find the coordinates of a and m. Let's find the coordinates of a first, and a is nothing but x-intercept of the curve, right? Whenever we want to find the x-intercept, just make y equal to 0 and we get x-intercept. So that means in place of this y we'll put 0 and we should get it. 4 square root x minus x. So whenever 0 equal to something, try to see if you can factor the other side. Yes, we can factor this. Square root x is common in these two. Okay, so square root x is taken common. What is left here? 4 minus, out of x, x can be written as square root x times square root x, right? So if square root x has been taken out, so remaining will be the another square root x here. And now since they are equal to 0, we can make them individually equal to 0. Either this is equal to 0 or 4 minus square root x is equal to 0. If we square both sides here, x equal to 0 is x-intercept, and we can see that this is x equal to 0, but that is not what we want. The other one will give us the coordinates of a. 4 equal to square root x, taken that side and square again. So x is equal to 16. So the coordinates of a are 16, 0. Second is find the coordinates of m. Now m is a turning point, stationary point, right? Maximum point they have written. The special property of a maximum point or a stationary point is that the gradient of the tangent is 0 because it's a horizontal line. And gradient of tangent is nothing but dy over d, a differentiation of the function. Let's differentiate this. Dy over dx equal to 4 is a constant, so 4 remains 4, but x square root x can be written, let me write here, x square root x can be written as x power half, and if we differentiate, this half comes in front and the exponent of x goes down by 1, so it becomes half x to the power half minus 1 is minus half, and you want to make it positive, it becomes 1 over 2 x to the power half. And that's what we'll write here. The differentiation of square root x we found is 1 over 2, and if you want to write square root x in place of x to the power half. Okay, minus the differentiation of x is 1, and that is what we'll get now. 2 and 4 can cancel, so we get dy over dx equal to 2 over square root x minus 1. And for stationary point, it has to be equal to 0. This becomes the equation, and we'll solve it now. So 2 over square root x equal to 1 when it goes to the other side. Let's complete it here. Square root x and 1 will cross multiply, so 2 equal to square root x, and square both sides again. X is equal to 4. The x coordinate of this stationary point is 4. And let's find the y coordinate. So for finding y coordinate, just put x coordinate in this and we'll get y. Let's see it. Y equal to 4 square root of 4 minus 4. So 4 times 2 is 8. 8 minus 4 is 4. So 4 is the coordinate. And we'll write here the coordinates of A were 16, 0, and the coordinates of M is 4, 4. Second part, find the volume obtained when the shaded region in this function is rotated through 360 degree about x-axis. Okay, so the whole thing is shaded, and we know it is from 0 till 16, right? And the way we find the volume along x-axis if it is rotated is this: pi and y square with respect to x from 0 to 16. So this is how we find the volume, and let's substitute the value of y. Y is 4 square root x minus x square and dx. So in place of y, we put its value, and now we'll integrate this. Pi 0 to 16. Okay, let's square this one. 4. Okay, we'll again do the same thing. Okay, a minus b whole square is a square plus b square minus 2ab. So square of 4 square root x will be 16x. 4 square is 16, and square root square will be just x, plus square of x is x square minus 2 times 4 square root x times x, and then dx. Alright, so the integration will be pi, integration of 16x will be 16x square over 2 plus x cube over 3, and this is minus 8. And square root x and x, square root x is 1 to the power half multiplied by x, that becomes x to the power 3 over 2. This is what we have to integrate here. X 3 over 2 plus 1 over 3 over 2 plus 1 plus c from 0 to 16 pi 16 times 16 square over 2 plus 16 cube over 3 minus 8 times 16 to the power 3 over 2 plus 1 is 5 over 2 over 5 over 2. Yeah, denominator of denominator is numerator, we can do this way, plus c minus, and I'll have to take this pi again, it is with both. Yeah, so 16 times 0 square over 2 plus 0 cube over 3 minus 8 0, and it doesn't matter because it becomes 0 plus c. So since this is 0, this is 0, this is 0, this c cancels with this, that means this is of no use. We just have to focus on the first part, which is pi. 2 and 16 cancel. 16 square is 256 times 8 is 2048. 16 cube 4096 over 3 minus 8 times 2 16 over 5 times 16 to the power 5 over 2. Let me use my calculator to find this value. It comes out to be 3276.8. And when I put my whole thing in my calculator, I get 136.54. So which will be about 137 pi units cube. That's the volume of the shape.